Chapter 18. We're going to discuss moisture, clouds, and precipitation in this chapter. Section 1 is over water in the atmosphere. So water in the atmosphere can be found in all three states of matter: gas, liquid, and ice. Hopefully you remember from elementary middle school the differences between the three states of matter. That gas is moving very quickly. That's considered water vapor. Liquid water would be actual water droplets that are touching each other, bouncing off each other. And then ice, they are moving so slow they actually form a crystalline structure. So solid ice, molecules arrange themselves into rigid patterns and they vibrate against each other. If we add energy, it can actually break them free. The phase changes that occur when its energy level changes, we can sublimate when we go from ice straight to a vapor. If we go from ice to a liquid, it's considered melting. Liquid water, the molecules are very close together, bumping and vibrating, moving at slightly different speeds. At the surface, there are some of them that acquire enough energy that they will actually break away and they'll form little air droplets. The phase changes that occur here, we go from a liquid to a vapor, which we call evaporation, or the latent heat of vaporization. We can also go from a liquid to a solid, or freezing, that latent heat of fusion. The gaseous form of water, or water vapor, the molecules are very far apart, zipping past each other, and it can be carried great distances. If a molecule loses up some of its energy, it can change phases. We can go from a vapor to a liquid, which we call condensation, and we can go from a vapor to a solid, or deposition, or depositing. In a covered glass, the number of molecules that are evaporating will eventually balance the number that are condensing. And that is the point in which we call saturation. That means that the air in the jar, the air in that parcel, is completely saturated, so it's equal. It's reached that equilibrium point. Okay, so the molecules that are escaping are evaporating, the molecules that are returning are condensing. And when they're equal, when they're balanced, we consider that saturated. So you may have felt the air is saturated before, and it's a very high humid state. So absolute humidity, if you hear them talk about that, they're talking about the mass of water vapor in a given volume of air. The specific humidity measures the mass of water vapor relative to the total mass of air in a parcel. The actual vapor pressure tells us what the water vapor pressure is. So just like air has pressure, the vapor is going to have a pressure as well. And the saturation vapor pressure is the pressure that water vapor molecules would exert if the air were saturated with vapor at a given temperature. So humidity in humans, you may have heard, it's not the heat, it's the humidity. So hot and muggy conditions can keep our body from sweating. When that happens, if your body can't sweat, it has no way to naturally cool itself, and so you inherently feel warmer. And you start to build up more and more heat inside your body because you have no way of getting it out. There's no way for it to escape. Hot, dry weather is going to be more comfortable because sweating can occur, and that is what keeps us cool. So a hot, humid day in Louisiana is going to feel very different than the same temperature in, say, Las Vegas because of the humidity levels. The most important thing when it starts getting hot that most of us take for granted is to stay hydrated. Quantifying humidity, we're going to talk about the dew point. You may have heard about the dew point if you listen to the weather, you listen to the newsmen, and they're going to talk about it, and it's just the temperature in which the air would have to be cooled in order for saturation to occur over a flat water surface. So a high dew point means that we have a higher overall moisture content. Low dew points mean that we have low overall moisture content. This is going to be important because when we start talking about cloud formation, those clouds form because the temperature as you're going up in the sky is going to change. And when it reaches the dew point, that's when the clouds begin condensing and forming. So we can see weather maps that show us the dew points. This is a January day. Our dew point is between here and here, 0 degrees. And then we have 10, 20, 30, 40, 50, 60. A lot of those dew points are going to correlate with the geography of the area. So notice that the mountain ranges are going to influence the shapes of those areas. So the dew point in July is going to look much different. So that's going to be influenced by the Gulf and the Rockies. And then the polar air that was pushing down in the previous slide is going to influence here. So temperature and dew point. When the air temperature and dew point are close together, we say that the relative humidity, or the RH, is high. When the temperature and dew point are far apart, the RH, or relative humidity, is low. If the temperature, the air temperature, falls below the dew point, then water will leave the air. You can see dew on the ground when this happens. And if the dew point happens to be below freezing, so 32 or below, it will freeze and you will see frost, which is why we see frost in the fall and the spring. The moisture will leave the air and it'll settle on the ground, which is why in the summertime when you go outside in the mornings the grass is wet, because that is all of the moisture from the air that has settled out because the air temperature got closer to the dew point and then it fell below. If it happens to be cold, it'll freeze, and that's when we see frost. So our example here, if the dew point is 20 degrees Fahrenheit and the temperature tonight falls to 26, will you see dew in the morning? Probably not, because the temperature didn't fall below 20 degrees. If it fell below 20 degrees, then we would see dew in the morning. It would actually be frozen. If it falls to 19 degrees, will you see dew or frost? Frost, because it's colder than freezing, so obviously. When the temperature and dew point are close together, you have a relative high humidity. If the dew point is 20 and the humidity is 60, what does that tell you about the temperature? Do you think it will be very warm, or will it be very cold feeling? Hopefully you said it's going to feel very cool, because the relative humidity would be very low. So dew formation. For example, if the dew formation is more likely to form on nights with clear skies and calm winds. Objects near the ground will emit infrared radiation on those clear nights. The coldest air here is located near the ground when we have calm winds. If the droplets freeze, so if the air temperature is below 32 degrees Fahrenheit, we'll end up with frozen dew, which is different than frost. The radiation cooling of the surface will cause us to form frost. So surfaces like grass, trees, cars will cool below the frost point, below freezing, and then the air temperature reaches the frost point, so the air becomes saturated. When the temperature and the dew point are equal, the deposition of ice onto surfaces occurs, and this is also known as hoarfrost or white frost. If you saw the movie Jack Frost, that was when he touched things, it became that branching pattern. So frost is not frozen dew. Frost will form on objects that are below freezing when the vapor lands on it, and frozen dew is a dew or a liquid that freezes as the temperatures themselves drop. Now haze occurs when there's lots of humidity or moisture in the air and there's lots of other particulate matter. The Blue Ridge Mountains are notorious for their hazy appearance. That is how they got their name originally, because it's kind of a blue haze that settles over the mountains. And a lot of that comes from all the trees, all the photosynthesis going on. There's a lot of transpiration, which puts a lot of moisture into the atmosphere. Now Los Angeles, most of what their haze is more pollution, but there's still quite a bit of humidity in there as well. So haze is just mainly dust or salt particles suspended in the air. In the morning, distant objects on the horizon are harder to see. That relative humidity is much higher, therefore the water vapor can condense more readily and fill the air. In the afternoon, on a hazy day, the distant objects on the horizon are easier to see. The RH is lower, therefore the water vapor doesn't condense like it does in the morning. So we have a lot of hazy days during the spring when farmers are plowing fields, or if they are burning a lot, we'll have super hazy days. So hygroscopic means water seeking. So some of that particulate matter that's suspended in the air would be like ocean salt. Hydrophobic is water repelling. So oils, waxes, gasoline, those types of byproducts that you would find. are going to give a different type of haze. The wet haze is when tiny liquid drops scatter light, and appear dull gray or white. So you would find that more with the hygroscopic particles. The dry haze, the non-water particles appear orange or yellowish. So they have kind of that yucky, dirty color in the sky. That brings us to fog, which is literally just a cloud that's in contact with the ground. Here in Missouri, all three of these pictures are very common. This would be fog that's laying over the river. This is fog like in a park. And then we've all probably seen a foggy morning driving down the road. So fog forms when condensation begins to form on less active nuclei, usually when the RH value, the relative humidity, is closer to 100%. The fog droplets can grow in size and eventually will fall to the ground. More than likely what happens is this occurs in the morning. The sun will come up and it'll start to burn off that fog, especially in early summer. Fog is formed in two ways. The first, cooling the air to its saturation point, or that dew point, and then evaporation and mixing occur, so there's more vapor content to the atmosphere. Fog is maintained by forming new fog droplets and adding moisture to the atmosphere. So puddles, lakes, recent storms, they can all leave puddles of water or areas of water that will evaporate off. So a lot of times in the fall and the spring, we'll actually see those little fog clouds that form over the tops of ponds. A type of fog is radiation fog, sometimes called ground fog or valley fog. This is formed by Earth's radiational cooling process. It happens on cool nights when there's a lot of moist air near the ground, so oftentimes after it's rained. And then there's going to be a drier layer of air above the ground level. So that causes the radiational evaporation of the moisture, and then it hits that drier air and it condenses and forms a fog layer. This is common over land in fall and winter, and it'll happen on clear skies and light windy nights, 3 to 5 mile an hour winds. The radiation fog often forms in valleys, so if you go to the mountains, you'll see this. The cold air will actually drain downhill, so cold air will sink, and it'll cause foggy conditions at the bottom. Radiation fog develops from the ground up. So where does it go? How do we get rid of it? Well, we just have to wait for the sun to come out. It warms up the ground, increases the temperature, and then the evaporation begins and the fog just evaporates away. It can also help if it's windy. That can mix the dry air from above the fog down, and it will cause it to dissipate. Advection fog is a little different. The warm, moist air will flow over a cool surface, and the transfer of warm air to cool air helps bring the temperature down to the saturation point, or that dew point. The air has to be moving in order for advection fog to occur. So the higher the wind speed, the more likely you are to have an advection fog. The warm, moist air from land blows across cool water, such as the fog near the Golden Gate Bridge. This is what we also see over the Missouri River, really foggy mornings over the Missouri River. We get that advection fog. So radiation fog versus advection fog. You're going to see that advection fog as that cold water, mild water. The wind is blowing. The cold air is sinking downhill in both situations. This is causing that radiation to rise because the cold air is pushing it out of the way. Light winds can actually bring that across, and you might see this down at the lake. Another type is called upslope fog. So the moist air will flow up along a hill, slope, or mountain, but as it rises, it cools, and eventually it reaches the dew point, and so it'll thereby reach this little cloud. So fog can form on the eastern slopes of the Rocky Mountains in late winter and spring and form this upslope fog. It's kind of neat looking, but again, it'll dissipate as soon as the sun comes up. Steam fog is going to happen when warm water, such as like a warm lake in fall after the first cold night, or a summer rain hits and the roadway has been really hot all day long. That steam fog comes from a moist layer of air that mixes with cool, dry air from above the water's surface. Hail fog is interesting because this is going to happen after a significant hailstorm. We know that hail comes in the summertime, even though it's ice. we're not going to run into hail in the winter time usually. It's more of a spring and summer thing. After that hail falls, it's going to melt pretty quickly, and that releases a lot of moisture in the atmosphere, and it'll thereby, the drastic changes in temperature will create a little fog cloud. So some of the foggiest areas of the country: the Pacific Coast over here, Oregon, Washington coastline, the Smoky Mountains, and New England. They have lots and lots of fog in those places.